The human brain is an extraordinary organ. It is the seat of our consciousness, the interpreter of our senses, and the storehouse of our memories. This complex network of billions of neurons allows us to remember our past, learn from our experiences, and shape our future. From the simplest sensations to complex emotions and personal histories, memories form the very essence of who we are. Imagine the brain as a vast and intricate palace, filled with countless chambers and corridors. Each memory, from a childhood pet's name to the taste of your favorite meal, occupies a unique space within this palace. But how does the brain transform fleeting experiences into lasting memories? The journey begins with encoding. This process involves converting sensory information from our surroundings into a form that the brain can store and access later. It's akin to a scribe meticulously recording events within the chambers of our memory palace. Memories are not merely static recordings, however. They are dynamic and ever-changing, influenced by our emotions, biases, and subsequent experiences. Every second, our senses are bombarded with a torrent of information. We see vibrant colors, hear a symphony of sounds, smell enticing aromas, taste delectable flavors, and feel a range of textures. This sensory input is the raw material of memory. The brain must first perceive and attend to this sensory information. Imagine trying to remember every detail of a bustling street scene. It's an impossible task. Our brains are selective, prioritizing information deemed important or relevant. Once sensory information gains our attention, it's encoded by specialized groups of neurons. This process strengthens the connections between these neurons, a phenomenon known as synaptic plasticity. These strengthened connections form the neural basis of our memories. Like a well-trodden path through a forest, the more frequently these connections are activated, the stronger and more enduring the memory becomes. Not all memories are created equal. Some memories, like the phone number you just looked up, are fleeting and fade quickly. These are held in short-term memory, a temporary holding space with limited capacity. Short-term memory acts like a mental scratch pad, allowing us to retain information for a brief period, typically a few seconds to a minute. However, without further processing, these memories dissolve like whispers in the wind. Memories deemed significant or repeatedly retrieved are transferred to long-term memory for more permanent storage. This process, known as consolidation, involves structural and chemical changes in the brain, particularly in the hippocampus, a seahorse-shaped structure deep within the brain. Long-term memory has a vast capacity, capable of storing a lifetime of experiences, emotions, and knowledge. It is within this vast repository that our most cherished memories reside. Storing memories is only half the battle. The true marvel lies in our ability to retrieve them at will, bringing the past back to life. Retrieval is the process of accessing and bringing stored information back into conscious awareness. Imagine searching for a specific book in a vast library. You might use keywords, titles, or authors to locate the desired information. Similarly, the brain uses retrieval cues to access stored memories. These cues can be internal, such as a thought or emotion, or external, like a familiar scent or melody. When we encounter a retrieval cue, it activates associated neural networks, triggering a cascade of activity that brings the target memory back into focus. This process is not always perfect, however. Memories can be distorted, influenced by our current knowledge, beliefs, and even the act of retrieval itself. The act of remembering is not a passive playback of a static recording. It is an active process of reconstruction subject to the nuances of our ever-changing brains.